Welcome back to day 13 of the Topic Blast revision series. Today's topic is compound measures. If you're not familiar with the concept of compound measures, it's things like speed, density, and pressure, and that's what we're going to focus on today. So have your booklet ready and we can start going through the answers to the questions provided. This first question is about speed, distance, time, and it gives us the distances travelled and the speeds they travelled at for three different people. Now, speed, distance, time tends to be something students find easy enough when it's a calculator question. However, in a non-calculator situation like this, it's where we get difficulties. So this is the way that I like to do this one. We'll start with Matt. Now it tells us that Matt is travelling at 68 miles per hour. That means he does 68 miles in 1 hour or in 60 minutes. And often with questions like this, it's easier to work in minutes. Now Matt is going to travel 34 miles. So we need to go to 34 miles. And looking at that, you should be able to see, well, that's just dividing by 2. So if we do the same thing on the other side, divided by 2, that means it's going to take Matt 30 minutes to get to his destination. If we do something similar for Benny, so Benny is traveling at 12 miles per hour. So again, that means 12 miles in 60 minutes or in 1 hour. And we're trying to travel 5 miles. Now getting straight to 5 miles, we can do in one go. We just need to find our scale factor. Now the scale factor we're going to use is we're going to do new divided by old. So we're trying to get to 5, so 5 becomes our numerator, and we currently have 12, so 12 becomes our denominator. And then all we have to do is multiply the other side by 5 over 12. Now remember, when we're multiplying by a fraction or finding a fraction of an amount, as we saw in an earlier video, we divide by the bottom and times by the top. So 60 divided by 12 gives us 5, and then 5 times 5 is 25. So it takes Benny 25 minutes. So far Matt takes the longest amount of time. Finally, we've got Pete. Now Pete travels at 3 miles per hour. So that's 3 miles in 60 minutes. And we want him to travel 2 miles. Once again, we're going to find our scale factor. It's going to be 2 because that's what we're trying to finish on, divided by 3 because that's what we currently have. On the other side, times him by 2 over 3, dividing by the bottom and multiplying the top gives us 40 minutes. So Pete takes 40 minutes, Benny takes 25 minutes, and Matt takes 30 minutes. So whose journey takes the longest time? The answer is Pete. Now in this question, it tells us that Anissa is doing sprint training. And it says on Monday, her fastest time to run 30 meters is 4 seconds. And on Tuesday, her fastest time to run 50 meters is 6 seconds. And it's asking on which day does she run faster. Now we can do this in the standard way that we normally would, which is that we would say that speed is equal to distance over time. So on Monday, we did a distance of 30 meters in 4 seconds. So 30 divided by 4 is the same as 15 over 2, which if we make into a decimal is 7.5 meters per second. If we look at Tuesday, Tuesday is 50 meters in 6 seconds, which again if we simplify is 25 over 3. And then if we simplify that, you might not be able to make it into a decimal, but into a simplified mixed number we might be able to do. So 3 into 25 goes 8 times, remainder 1. So it's 8 1/3 meters per second. Now we can clearly see that 8 1/3 meters per second is bigger, so therefore the answer is Tuesday. So she ran a faster average speed on Tuesday. Now in this question we're moving on to density. What we need to remember for this is that density is equal to mass divided by volume. So we're given the density of water and of oil, and we're told that if we have 2 liters of water and oil, calculate the difference in the masses of the two liquids. And then we're also given this conversion of 1 liter equals to 1,000 centimeters cubed. So first of all, we're going to take these 2 liters and we're going to convert those into centimeters cubed, because that's the units we need to use for volume when we're given the density. The reason we know that is because of these units up here. They use centimeters cubed, so we have to use centimeters cubed here. So that gives us 2,000 centimeters cubed. So therefore, if we're working out the mass of the water, okay, if we rearrange this formula, mass is just density multiplied by volume. So therefore, we get the density of 1 multiplied by 2,000 centimeters cubed. That gives us a mass of 2,000. Too many zeros. 2,000 grams. If we work out oil, that's 0.7 for the density times the same volume, 2,000 centimeters cubed, and that gives us 1,400 grams. Now it asks us to find the difference in the masses. Difference just means we subtract. So we're doing 2,000, take away 1,400, and the difference is 600 grams. Now in this question we're given the dimensions of a cuboid and we're given the mass of the cuboid and we're asked to find the density of the material. Now because we're working in centimeters up here, that means our volume is going to be in centimeters cubed, and the units which it asks us to state that we use for density is either grams per centimeter cubed or kilograms per meters cubed. What we're going to use is, we're going to use this one in this case because I think it's slightly easier. So this 12 kilograms, well there's 1,000 grams in a kilogram, so that's 12,000 grams. Now if we work at the volume of our cuboids, the volume of a cuboid is the length times the width times the height. So we've got 20 times 30 times 40. So 3 times 2 is 6, 6 times 4 is 24, and then we can put our 3 zeros on the end. So we get 24,000 centimeters cubed. And then as we saw in the last question, density is equal to mass divided by volume. So therefore we've got 12,000 divided by 24,000, which if we simplify, we can cancel some of our zeros. We've got 12 over 24, which simplifies to a half. Now often it's nicer to write this as a decimal, so it's 0.5, and then our units, as we said above, are grams per centimeter cubed. So in some cases you may have to work at the volume before you can then figure out the density. In other cases you might just be given the values to work with. So our answer here again, as I said, was 0.5 grams per centimeter cubed. So the third compound measure we're looking at, as I said, was pressure. This one says if a nail is hit with a force of 750 newtons and the area of the tip of the nail is 0.001 centimeters squared, calculate the pressure exerted. Now pressure, and you may not be as familiar with this formula, pressure is equal to the force applied, or force, divided by the area of contact, or the area. So very simply in this one, pressure equals 750 newtons divided by 0.001 centimeters squared. Now, often it's easier when we're doing these questions to actually ignore our units, which is what we're going to do in this case. So to get this, when we're dividing by a decimal, what we want is we want to get rid of the decimal on the bottom. So in this case, we're going to have to multiply by 1,000, and we're going to do the same on the top. That gives us 750,000 divided by 1, which is simply just 750,000. Now we need to figure out our units. Now our units, remember if we go back and put our units back in, this was newtons and this was centimeters squared. So we've just done newtons divided by centimeters squared, and that's how we can work out our units. And that works for any compound measure. So the answer here is 750,000 newtons per centimeter squared. So this question again is about pressure, and it says a glass window will break if it's hit with a pressure exceeding 9,000 newtons per meter squared. It also tells us if the area of the head of a hammer is 0.2 meters squared, calculate the minimum force needed to break the window. So that is that minimum force. So going back to our formula, pressure equals force divided by area. Let's sub in what we know. Well, we know the pressure is 9,000. We'll leave out our units to make it a little bit easier for ourselves. The force we're trying to find, we'll just call that x, and the area is 0.2. We're then going to solve this equation. We can multiply both sides by 0.2, and that just gives us an answer of x equals 1,800. So the force needed is 1,800 newtons. Now these next 6 questions are the same 3 compound measures, but we just use a calculator. Now using a calculator often makes this process easier, so we've changed up the context a little bit to give us a different perspective of how these questions might be asked. So in this one it says Sinead is training for a half marathon. She wants to run an average pace of 5.5 minutes per kilometre, or she wants to run 1 kilometre in 5.5 minutes. And the question asks us what average speed will she need to run if she is to achieve her goal. And it says to give your answers in kilometres per hour. So we're going to do this the same way we did the non-calculator question at the start. We have 1 kilometre is equal to 5.5 minutes. And we want to know, well, how far will she run in an hour or in 60 minutes? Again, using our scale factor, which is times by 60 over 5.5. And again, this might seem, well, actually that's a little bit more complex to do. But remember, we've got a calculator in this question, so our calculator will do all the work for us. Now that, when we put in our calculator, will give us 10.90 recurring kilometres. So that means in 1 hour she'll run 10.90 recurring, or 10.91 kilometres. So therefore her average speed will need to be 10.9 kilometres per hour. So another way it can be asked speed, distance, time is when you're given what I like to refer to as a broken journey, where you're told some information about the first part of a journey, the second part of a journey, and you have to figure out the missing information. So in this case, it tells us that Catalina is driving 349 kilometers from Madrid to Mauritius. For the first part of her journey, she drove for 1.5 hours at an average speed of 94 kilometers per hour, and also that her entire journey took 4 hours. The question is, did she drive faster or slower in the second half of her journey, and by how much? So it's not just about saying faster or slower, we have to say by how much. Now I like to use a very simple diagram for this. So there's my start point, there's my middle point, and there's my end point. This doesn't need to be proportional, it's just a nice way to identify this and to lay it out so you can follow what you're doing. I like to put my distances on top and then my times and my speeds underneath. So the first part, 1.5 hours at 94 kilometers per hour. And the second part, because we know it took 4 hours in total, we know the second part of the journey must have taken 2.5 hours. And then we don't know the distances. The only information we know about the distance at the moment is that the overall distance was 349 kilometers. So let's work out the first part. The distance, again rearranging that formula that we know, the distance that she traveled is equal to the speed multiplied by the time. So that's going to give us 94 times 1.5, which gives us 141 kilometers. So this first part is 141 kilometers. Therefore, we can figure out the second part of the journey because it's just 349 minus 141, which gives us 208 kilometers for the second part of the journey. So this is 208 kilometers. Now what we need to do is figure out the speed, and remember speed is distance divided by time. So the speed here is 208 divided by 2.5, and the speed then that she drove in the second part was 83.2 kilometers per hour. So we put that over here, 83.2 kilometers per hour. So the answer here is that she drove slower in the second half. And by how much? Well, we'll just do 94 minus 83.2, which gives us 10.8 kilometers per hour. So slower by 10.8 kilometers per hour. Looking again at density, it tells us gold has a density of 19.32 grams per centimeter cubed, and silver has a density of 10.49 grams per centimeter cubed. It says Orla has a piece of metal that she believes is either gold or silver. It has a mass of 136 grams and she has estimated the volume as 13 centimeters cubed. The question asks us, is the metal itself more likely to be gold or silver? So very quickly, all we have to do is figure out the density. Remember, density is mass divided by volume. So the mass here is 136, the volume is 13, and if we do 136 divided by 13, again using our calculator, that gives us 10.46, etc. grams per centimeter cubed. So therefore, clearly comparing that to gold and silver, it's more likely to be silver. Very simply. So second density question here. It tells us the concrete has a density of 2.4 grams per centimeter cubed, and a pile of 25 blocks of concrete have a mass of 960 kilograms. It then says to work at the volume of one block of concrete. So let's start by working at the mass of one block. Now the mass of one block of concrete is the 960 kilograms divided by 25 blocks, which tells us that each block is 38.4 kilograms. Now that's not much use to us because we want our densities in grams per centimeter cubed. So we need that in grams. So in grams, remember there's 1,000 grams in a kilogram, so we're going to multiply that by 1,000, which gives us 38,400 grams for one block. Now we can figure out the volume. So the volume is mass divided by density, so 38,400 divided by the density of 2.4, and that tells us the volume of one block is 16000, or 16,000 centimeters cubed. Be conscious they may ask you to write your answer in meters cubed. In this case it doesn't specify, so we can just leave it as centimeters cubed. Finally on to pressure again. So again we're using a calculator in these two questions. It says Ella is conducting an experiment of how hard she can kick a football. She has a football with a sensor inside to measure the pressure and force exerted on the ball. Ella's highest reading was 150 newtons for force and 280 pascals for pressure, and it asks us to calculate the area. Now one thing we need to be aware of is that a pascal, so 1 pascal is equal to 1 newton per meter squared, and that's really important here because that then allows us to work out the area, and we know the units for the area is in meters squared. So as we know, pressure is equal to force divided by area. Summing in the information we know, the pressure is 280, the force is 150, and the area is what we're trying to find. Now if you've watched the video on solving equations, you'll know that if our unknown is on the bottom, we can just swap these two things around to give us our answer of area is equal to 150 over 280, or if we put that in our calculator and get a decimal, we get 0.535, etc. And again, that's meters squared. So then our answer to sensible rounding, 0.54 meters squared. So that was the area of contact. So the last question here is a classic when it comes to talking about pressure, and it's which exerts more pressure, an elephant or someone in a stiletto heel. So in this question we're told an African elephant standing on 1 foot exerts a force of 60,000 newtons, and that the area of 1 foot is 0.6 meters squared. It then says Gina is standing on only the heel of 1 high heel shoe. She exerts a force of 700 newtons, and the area of the heel is 2 centimeters squared. Given that 1 centimeter squared is equal to 0.0001 meters squared, which exerts more pressure, and we have to state our units. Now normally for pressure we use newtons per meter squared, so let's convert this one first. So using the scale factor that we're given, we can quickly see that this is 0.0002 meters squared. And now we can just work out our pressures. So for the elephant, we're doing pressure is force divided by area, so that's 60,000 divided by 0.6, and 60,000 divided by 0.6 is 100,000 newtons per meter squared, or pascals if you prefer. Then for Gina, she obviously exerts a much smaller pressure of only 700 newtons, but she's also got a much smaller area, which is 0.0002. And if we do that calculation on our calculator, we get 3.5 million, or 3,500,000 newtons per meters squared. Now that's not enough. The question says, which exerts more pressure? The answer to the question is Gina. As always, thank you so much for watching. I hope you found this video useful and it helped you answer those questions that you were finding a little bit tricky. If you want to see all the videos in the series so far, click the playlist below and we'll see you in the next video.